today we're going to be looking at 7.2 and 7.3, which is quadrilaterals and parallelograms. So I have my math journal here, and I also have some note cards, because what we're going to be doing during this chapter is we're going to be building a quadrilateral family tree. So last time we talked about polygons. Remember, polygons were many-sided figures. Polygons are going to break apart into different types of figures. You know, we talked about quadrilaterals, triangles, pentagons, hexagons, heptagons, all of those things. One specific type of polygon is a quadrilateral. Now I know you've heard this word before, quadrilateral. Can't talk and spell at the same time. A quadrilateral is just any four-sided figure. So I'm going to use my note card here, and you can use your note card too. We're going to be referencing them as we take notes going forward. Come on, focus for me. There we go. And a quadrilateral is any four-sided figure. So I'm just going to draw a random four-sided figure here. Nothing special about it. Just four sides, right? So any four-sided figure is a quadrilateral. I'm just going to leave this here. And going to our notes page, you can just kind of see what a quadrilateral is. These on the right, these are examples of quadrilaterals, four-sided figures. Notice that the types on the right are not quadrilaterals, because here we see we have a curved side. This is not a quadrilateral. Here we have some intersection points. This is not a quadrilateral. This is two triangles. And then here we don't even have a figure that's closed. So this is not a these are non-examples here. On the left, these are examples. And then we're going to be moving a little bit closer down into our quadrilaterals. We're going to be talking about parallelograms. So I'm going to use, I don't know, this card that I have here to talk about parallelograms. So parallelogram. And a parallelogram is a specific type of quadrilateral. I'm going to draw one here for us. And you can kind of see what it's going to look like. But a parallelogram has very specific properties. So I'm going to draw those properties here, and then on the back, I'm going to write them out. So we're going to actually do something with these cards later on. So if you don't have note cards, you can just write this in your math journal. I'm going to draw some arrows here, and I'm going to draw arrows here. And I know that you've seen these arrows before, and we're going to talk a little bit more about them. And I'm going to draw tick marks, so you can kind of see what's going on. And I'm going to do one more thing. Not go all the way. Just have to make it go all the way eventually. These are called diagonals here. And something happens with the diagonals. So, all right, so we have a bunch of different tick marks, and we're going to talk about properties of parallelograms. So I'm going to write them down here on my math journal, and then I'm also going to write them down on the back of my note card. So there are 5 properties of parallelograms. The first property is that opposite sides, oh, I missed one, didn't I? And opposite angles. So let's see, we have 1, 2, 3, 4, Okay, so opposite sides are congruent. So if you notice, I marked that with the tick marks here. So my opposite sides are congruent. Second is opposite angles are congruent. Third, so if you notice, our opposite angles are congruent. Third, our opposite sides are parallel. That's where we get our name parallelogram, right? Parallel, it's in the name. And then fourth, our diagonals bisect each other. So bisect, remember, means to cut in half. So in this case, this diagonal here is bisecting this diagonal, so they're cut into equal parts. The fifth one here is a little bit different. Because we're dealing with a parallelogram, we have consecutive angles here. Remember when we were talking about parallel lines cut by transversal, your same side interior angles are supplementary. So in here, we're going to say consecutive angles are supplementary. What does supplementary mean? Supplementary means they equal 180 degrees, right? They add to equal 180 degrees. So I'm going to put that little note there. So remember, this means congruent. They have equal measure, equal length. This also means congruent. They have equal measure, equal degree. This is parallel, and then bisect each other, cuts in half, and consecutive angles are supplementary. Let's look at some examples here as we go through. So let's look, which ones do we want to do? Let's start with example 3. Example 3 down here. Yeah, I want to. Yeah, let's start with example 3 down on page 4. I know it's a lot of pages. So we have a parallelogram here. It's given us this picture here. I'm going to draw it on my notes. Bisecting D, A, E, B, C. So it tells us first, here you can kind of see my notes here. For example 3, name the parallelogram. You name the parallelogram using the vertices here. So this is parallelogram ABCD, like that. Now AB is parallel to DC. DA is congruent. See here, DA is here. Opposite sides congruent. Is congruent to CB. Angle CDA is congruent. Opposite angles are congruent. CDA, that's this angle here, is going to be congruent to the opposite angle ABC. And then lastly, letter E, side DE is congruent. So we have DE, oh, this is our, that's our diagonal, but it's only half of our diagonal because we know that the diagonal gets cut in half by the other one. So it's going to be congruent to this other side of the diagonal, EB. So we have letter A, parallelogram ABCD. We have letter B, opposite sides parallel. Letter C, opposite sides congruent. DA is congruent to DCB. D, our opposite angles are congruent. And then E, that qualifies our diagonals bisect each other. So we have all of our properties here. All right, so let's put a little bit of math to it. If ABCD, this is example 4, let's do example 4 together. We don't have a picture here, but we're going to follow our steps, which the first one is label, right? So that means I need a picture to label. If we have ABC, parallelogram ABC, so A, B, C, oh, D, sorry, is a parallelogram. The measure of angle A is X degrees, and the measure of angle D is 2X minus 3. Find the value of X. Well, what do we know about, remember these are consecutive, meaning one right after the other. A and C would be opposite. A and D are actually consecutive. So what do we know about our consecutive angles? They're supplementary. They equal 180 because of the parallel lines cut by a transversal. So I know that my angles are going to be supplementary, meaning I can add them together, right? That's minus 3 equals 180. So what do I do first? Combine our like terms. So we have 3x minus 3 equals 180. Add 3 to the other side. 3x equals 183. Divide by 3 is my last step. So we have x equals 61. So my question is, find the value of x. We did that. We don't have to plug back in. 61 is your value of x. Okay, so when we're solving the equation, we're going to follow our steps. Remember, label, write the equation, which we did here, right? Because we know that they equal 180. Solve, and plug back in. Well, in this case, we didn't have to plug back in. They just asked us to solve, so we're good to go. All right, let's look at example number 5. Example 5 says, XYZW is a parallelogram with diagonals that intersect at point A. So let's see. Drawing first, then we can label. Our parallelogram X, Y, Z, W. Notice that when I'm labeling in a clockwise rotation, okay? So we have our diagonals. So I'm going to just go ahead and connect our opposite angles here to create diagonals. X, Z, Y, W, they intersect at A. So I'm going to put A right here. If XA is 3M, so from X to A is 3M, and Z to A is 5M minus 4, and YW is 10M, so Y to W is 10M. Find M. That's a lot there. Okay. They're giving us some extra information. 10M. What do we know about the diagonals of a parallelogram? Let's look back here and see. Diagonals bisect each other. That means that my diagonals are cut in half, creating 2 equal segments, right? So if I look here, my diagonals bisect each other. This is extra information, right? That's extra. We don't need that. All we need are these 2. What do I know about those 2? If the diagonal bisect each other, that means that they are equal, right? 2 equal parts. So when I set up my equation, we labeled, now my equation is that they're equal to each other. 5m minus 4, right? So let's go ahead and solve this. I'm going to subtract 5m to the other side. So I have negative 2m equals negative 4. Divide by negative 2, don't lose that negative sign, m equals 2. So what do I do with the rest of this? It is asking me to just find m, so I don't have to plug in. M equals 2 is your answer. Let's keep going. Example number 6. We'll do 6, 7, and 8. Yeah, we'll do 6, 7, and 8, and then we'll do the next one in class. So here's 6. We have a funky little angle coming out the side here. So we have Z, X, that's an 80 degrees, and I think it's a V. So we want to solve for X, Y, and Z. Oh wait, that must be a Y. Y. So what do we know about these angles? Let's look back at our notes. What do we know about angles? There's a couple of different things. Opposite angles are congruent, and consecutive angles are supplementary. So that's the 2 things that I know about angles. Opposite angles are congruent, and consecutive angles are supplementary. So if opposite angles are congruent, then X would be congruent to 80, right? So X in this case equals 80 degrees. What else do I know? I know that consecutive angles, 80 and Z, and 80 and this angle here are going to be supplementary, meaning that 80 plus Z equals 180. Therefore, Z equals, 100. I skipped a subtraction step. So X equals 80. This one equals 100. Opposite angles are congruent. This one equals 100. And this is prior knowledge here. Kind of crazy here. If they're a linear pair, this one would also equal 80 because they equal 180 together. So X equals 80. Y equals 80. And Z equals 100 degrees. All right, nice job. Okay, let's look at number 7. Draw and label first. Always key. It always helps to draw and label. Even if you're like, I don't really know what to do, start with drawing and labeling, and then sometimes that helps. All right, we have a diagonal here. So this is 120. I have a Y here, a 35 degrees here. I think this is X degrees and Z degrees. All right, so what do I know about angles? My opposite angles are congruent, right? So if this is 120, then I know Z is also 120. That's my opposite angle. That's one answer. Then I have some funky stuff going on here. Well, what do I know about these? These are going to be congruent, right? But it's split in half. So thinking about those parallel lines cut by a transversal, if this is 35, then this one's 35 because it's alternate interior angles, right? So Y is going to be 35 here. And this is 120. So Y equals 35. Then we have to use some deductive reasoning because we have a triangle here. So I know that this 120 plus 35 plus X equals 180 because it's a triangle. So if I use my math here, that's 155. And if I subtract 155, what do we get? 25. So X equals 25. That one was a little bit tricky. It didn't really have a whole lot to do with our properties. Okay, let's go back up to the top because I want to talk about naming, right? That we want to make sure that we're naming these correctly. So let's look at example 1. Going back up to the top, example 1, we did example 3 together. This is our parallelogram at the right. Naming is very important, okay? So we have NPOM, and we talked about naming them in clockwise order. So naming this would be parallelogram. You can draw the little figure there. You can't see, yeah, you can see what I'm doing. NPOM would be a correct term. If you said POMN, that'd be okay too. If you said MNPO, that would be correct too. Any one of those as long as you're going in order, okay? Opposite sides of MN and MNPQ. Oh, that's a Q, not an O, huh? MNPQ. Opposite sides of MNPQ, let's look. Remember, opposite sides are congruent. So I'm just going to name this. NM is congruent. NM is congruent to PQ. What else are opposite sides? NP is congruent. NP is congruent to MQ. Biggest thing here is just labeling correctly, right? Opposite angles of MNPQ, let's see, right here. So opposite angles are congruent. Angle N is congruent to angle Q. Likewise, angle M is congruent to angle P. Opposite sides angles are congruent. And consecutive angles, remember, consecutive angles equal 180. So that means one right after the other. N and M equal 180. What else? P and Q equal 180. What else? Look, these two equal 182. So M and Q equal 180. And these two up here, P and N equal 180. So naming and labeling is super important. And we'll continue to talk about parallelograms, and we'll build our quadrilateral family tree. Right now, we have a quadrilateral, and then we have a parallelogram right after it. So a parallelogram is always a quadrilateral, but not all quadrilaterals are parallelograms.